In the last few years, it feels like the planet has been on fast forward. Headlines scream of unprecedented floods, continent-spanning wildfires, suffocating heat waves, and hurricanes that defy categorization. It's a relentless barrage of extreme weather that leaves us wondering, is the world falling apart, or are we just noticing more? The answer is complex, but it's not a mystery. It's an equation. Here's the truth. Nature's hazards, the storms, the earthquakes, the droughts, have always existed. They are a fundamental part of our planet's operating system. A hazard only becomes a disaster when it intersects with human society, specifically when it meets people who are exposed and vulnerable. So the question isn't only are storms getting stronger, it's also who and what have we placed in harm's way. To understand why disasters feel so frequent and intense now, we need to examine every part of this equation. Let's start with the hazard itself and the unmistakable climate signal. For over a century, human activity has been pumping greenhouse gases into the atmosphere, trapping heat. Think of it as adding extra blankets to the planet. This retained energy doesn't just raise the average temperature, it supercharges the entire climate system. We are loading the dice for more extreme events. The most direct consequence is in the air we breathe. A warmer atmosphere is a thirstier atmosphere. For every degree Celsius of warming, the air can hold about 7% more moisture. It acts like a giant sponge, soaking up more water from oceans, lakes, and land. But what goes up must come down. When conditions are right for a storm, this supersaturated atmosphere can unleash that moisture in torrential downpours, overwhelming drainage systems, and triggering devastating flash floods. This extra heat also bakes the land. Hotter, drier conditions parch landscapes, turning forests and grasslands into tinderboxes, primed for wildfires that burn bigger, faster, and more intensely than ever before. And then there are heat waves. These aren't just uncomfortable summer days, they are silent, invisible killers. The added energy in the climate system is making them longer, hotter, and far more frequent. High-pressure systems can stall, creating heat domes that trap blistering temperatures over cities and regions for weeks, pushing human bodies and our infrastructure to their absolute limits. Heat is already the deadliest weather disaster, and its threat is growing exponentially. The oceans have absorbed over 90% of this excess heat. That staggering amount of energy acts as fuel for tropical cyclones. Warmer oceans can rapidly intensify hurricanes and typhoons, turning a tropical storm into a monster Category 5 in a matter of hours. This heat also causes water to expand, a process called thermal expansion. Combined with meltwater from glaciers and ice sheets, it's causing global sea levels to rise. This means the same storm now rides in on a higher baseline, pushing storm surge deeper inland and flooding places that rarely, if ever, flooded before. The 100-year flood is becoming a decadal, or even more frequent, event in many coastal communities. But a stronger storm hitting an empty ocean is just a weather event. The second part of our equation is exposure. What and who is in the path of the hazard? In the last century, the human population has exploded, and we have overwhelmingly chosen to live in cities. Today, more than half the world's population are urban dwellers, and many of the world's largest megacities are situated directly on coasts, in river deltas, or on floodplains, areas inherently exposed to storms and flooding. We've built gleaming towers and sprawling suburbs right where nature needs to breathe. We've paved over wetlands and marshes that once acted as natural sponges, soaking up floodwater. We've cut down forests that anchored slopes and prevented landslides. We've built communities right up to the edge of fire-prone wildlands. When a hazard strikes these densely populated and developed areas, there is simply more to damage, more to lose. This brings us to the third, and perhaps most critical factor: vulnerability. This is the element that determines whether a community bends or breaks when a hazard hits. Inequality is the great amplifier of disaster. The same storm can be a costly nuisance for a wealthy family in a well-built home, but a life-altering, poverty-inducing catastrophe for a low-income family in substandard housing. Vulnerability is shaped by social and economic factors. Poorly constructed homes, aging and neglected infrastructure like levees and power grids, a lack of savings or insurance to buffer the financial shock, and limited access to healthcare all turn a bad day into a generational tragedy. When evacuation orders are issued, who has a car and a credit card to leave, and who is left behind? After the storm passes, whose neighborhood gets its power restored first? Vulnerability explains why communities of color and low-income populations consistently suffer the most severe impacts from disasters, even when they contribute the least to the underlying climate problem. On top of these long-term trends, we have natural climate variability. Cycles like El Niño and La Niña, the warming and cooling of the equatorial Pacific, have always shifted rainfall and temperature patterns around the globe, causing droughts in some regions and floods in others. Now, when these natural cycles align with the supercharged baseline of a warmer world, the extremes can spike dramatically. A strong El Niño year on top of long-term warming can lead to record-shattering global temperatures. And finally, there's perception. It's true that our vast network of satellites, ground sensors, and the smartphone in every pocket means we now see and share events in real time that might have gone unreported decades ago. We are more connected and more aware. But this heightened awareness doesn't negate the physical reality. Better detection is only a small part of the story. The hazards themselves are changing. So let's look at specific hazards. Take wildfires. They are driven by a cocktail of heat, drought, wind, and available fuel. Climate change is dialing up the heat and drought. But there's another factor. For decades, our policy was to suppress every single fire. This well-intentioned strategy allowed forests to become unnaturally dense with flammable undergrowth, the fuel. Now, when a fire starts in these overloaded landscapes during a heat wave, it can explode with terrifying speed and intensity. Add to this the rapid expansion of homes into what's called the wildland-urban interface, and you have a recipe for catastrophic loss of life and property. Or consider floods. As we've seen, a warmer atmosphere unleashes heavier rain. But where does that water go? In cities, it falls on concrete and asphalt, hardened, impermeable surfaces that prevent it from soaking into the ground. Instead, it funnels rapidly into storm drains, which are often undersized for these new rainfall rates, causing streets to become rivers. Along major waterways, rivers that once spilled harmlessly into natural floodplains are now hemmed in by levees. This constricts the flow, raising water levels and increasing pressure until the levee is overtopped or fails, sending a wall of water straight into the neighborhoods we built in the river's historic path. And what about storms? Warmer oceans feed them energy. Rising seas amplify their storm surge. But we're also seeing changes in their behavior. Some research suggests that climate change may be weakening atmospheric steering currents, causing storms to move more slowly. A slow-moving hurricane can linger over a single area for days, dumping catastrophic amounts of rain, as we've seen in recent years. We're also seeing more compound events, a deadly combination of hazards striking at once. Imagine a heat wave and drought that primes a landscape for fire, followed by strong winds that fan the flames. Or a hurricane that brings not only a devastating storm surge from the sea, but also extreme inland rainfall, a dual flooding threat that overwhelms every defense. So, can we prove climate change one specific event? That's the wrong question. Scientists use a field called attribution science to calculate how warming changed the odds. They can now say with confidence that a particular heat wave was made 10 times more likely, or that a storm's rainfall was 15% more intense because of the world we've created. The picture is daunting, but we are not powerless. If we can change any part of the disaster equation, we can change the outcome. We can reduce risk long before a disaster strikes. This isn't just about building bigger walls, it's about working with nature. We can restore the wetlands, mangrove forests, and coral reefs that act as powerful natural buffers against coastal storms. We can use prescribed fire and strategic forest thinning to reduce wildfire fuel loads and make our ecosystems healthier. We can build smarter, elevating homes in flood zones, using fire-resistant materials in high-risk areas, and designing sponge cities with green roofs and permeable pavements that absorb rainwater instead of shedding it. Crucially, we must stop building new homes and critical infrastructure like hospitals and schools in known flood zones and fire corridors. And we must invest in early warning systems. Heat action plans, smoke alerts, clear evacuation routes, and regular community drills save lives. Being prepared doesn't mean being scared, it means being ready. On an individual level, the first step is to know your local risks. Look up your address on official flood and fire maps. Does your home need retrofitting? Can you create defensible space around your property? Do you have a go bag packed with essentials? Do you know your community's evacuation zones and routes? On a collective level, we must accelerate the transition to a resilient society. This means tackling the root cause by cutting emissions with cleaner energy and more efficient buildings. It means upgrading our infrastructure to withstand the climate of tomorrow, not the climate of yesterday. The world isn't ending, but the era of predictable, average weather is over. We are now living in the age of extremes. By understanding the full disaster equation, the hazard, the exposure, and the vulnerability, we can make smarter choices. We can build a world that is not just safer, but more just and resilient for everyone. If you want a follow-up guide tailored to your region, tell us where you live and subscribe for the next episode.